compile topographic maps made from measurements and photographs, initiative photogrammetry involves objects from their photographic image and significance. Critical factors considered in identifying object of shape, sizes, patterns, and shadows, etc. And coming to the last one, that is classification based on object of survey. It is again subdivided into engineering survey, military survey, mine survey, geological survey, archaeological survey. Coming to engineering survey, this is undertaken for the determination of quantities or to afford sufficient data for the designing of engineering works such as roads, reservoirs, dams, and so on. And also those connected with sewage disposal or water supply bodies. Military survey is used for determining points of strategic importance. Coming to mine survey, this is used for exploring mineral wealth. Whereas in geological survey, it is used for determining different strata in Earth's crust. Coming to archaeological survey, this is used for unearthing relics of the antiquity. So, up to now, we have discussed about the conventional surveying. Okay, now let us see some of the conventional instruments. The conventional surveying instruments are like different types of chain, different types of tapes, different types of magnetic compasses, rough compass, and ranging rods, offset rods, and so on. Let us have it a glance.
AC of
So up to now, we have discussed about the conventional surveying. Now, let us enter to our main topic. The talk of the day is the modern surveying. So let us have a glance about the modern surveying instruments which are used. So coming to today's topic, that is importance of modern surveying instruments. In conventional surveying, chain and tape are used for making linear measurements, while compass and ordinary theodolites are used for making angular measurements. Leveling work is carried out using a dumpy level and a leveling staff. With the surveying instruments, survey work will be slow and tedious. Modern surveying instruments provide faster and more precise surveying than conventional instruments. Hence, modern surveying instruments are becoming more popular and they are gradually replacing the old surveying instruments such as compass and dumpy level. With modern surveying instruments, survey work will be precise, faster, and less tedious. So the types and uses are discussed here. So the modern surveying instruments and their uses. Following are the modern surveying instruments which are used for surveying. The first one is the electronic distance measurement, EDM instruments. Second one, total station. Third one, GPS, that is global positioning system. And last one is the automatic level. Coming to first one, EDM, electronic distance measurement instruments. The direct measurements of distances and the directions can be obtained by using electronic instruments that rely on propagation, reflection, and reception of either light waves or radio waves. They may be broadly classified into three types. The first one is the infrared wave instruments, second one is the light wave instruments, and third one is the microwave instruments. Coming to first one, infrared instruments. These instruments measure distances by using amplitude modulated infrared waves at the end of the line. Prisms mounted on target are used to reflect the waves. These instruments are light and economical and can be mounted on theodolites for angular measurements. The range of such an instrument will be 3 km and the accuracy will be plus or minus 10 mm. Examples for infrared wave instruments are Histomatch DI1000 and Histomat DI5. Histomat DI1000, it is a very small, compact EDM, particularly useful in building construction and other civil engineering works, where distance measurements are less than 500 meters. It is an EDM that makes a meaning tape hidden edge. To measure the distance, one has to simply point the instrument to the reflector, touch a key, and read the result. Coming to light wave instruments, these are instruments which measure distances based on propagation of modulated light waves. And example for the light wave instrument is the geodemeter. And the range of this light wave instruments is about nearly 3 kilometers. Now let us see the working and operation of the geodemeter. So, geometer is an instrument which replaces the chain and makes us our work very easily in taking the measurements and calculating the length of the Earth's surface. Geometer is an instrument which works based on the propagation of modulated light waves. Geometer was developed by E. Bergstrand of the Swedish Geological Survey in collaboration with the manufacturer MS AG of Swedish. The instrument is more suitable for nighttime observations and requires a prism system at the end of the line for reflecting the waves. Coming to microwave instruments, these instruments make use of high-frequency radio waves. These instruments were invented as early as 1950s in South Africa by Dr. T.L. Wadley. The range of these instruments is up to 100 kilometers and can be used both during day and night. An example for microwave instrument is a tellurimeter. So whatever the image is an instrument called tellurimeter. It is an EDM which uses high frequency radio waves, that is microwaves, for measuring distances. It is a highly portable instrument and can be worked with 12 to 24 volt battery. For measuring distance, two tellurimeters are required, one to be stationed at each end of the line with two highly skilled persons to take observations, and one instrument is used as a master unit and the other as a remote unit. Just pressing a button, a master can be converted into remote unit and vice versa. Speech facility, communication facilities provided to each operator as a remote unit. Just now let us have a master can be converted into remote unit and vice versa. Speech facility, communication facilities provided to each operator as a remote unit. Just now let us have a master can be converted into remote unit and vice versa. Speech facility, communication facilities provided to each operator as a remote unit. Just now let us have a master can be converted into remote unit and vice versa. Speech facility, communication facilities provided to each operator as a remote unit. Just now let us have a master can be converted into remote unit and vice versa. Speech facility, communication facilities provided to each operator as a remote unit. Just now let us have a master can be converted into remote unit and vice versa. Speech facility, communication facilities provided to each operator as a remote unit. Just now let us have a master can be converted into remote unit and vice versa. Speech facility, communication facilities provided to each operator as a remote unit. Just now let us have a master can be converted into remote unit and vice versa. Speech facility, communication facilities provided to each operator as a remote unit. Just now let us have a master can be converted into remote unit and vice versa. Speech facility, communication facilities provided to each operator as a remote unit. Just now let us have a master can be converted into remote unit and vice versa. Speech facility, communication facilities provided to each operator as a remote unit. Just now let us have a master can be converted into remote unit and vice versa. Speech facility, communication facilities provided to each operator as a remote unit. Just now let us have a master can be converted into remote unit and vice versa. Speech facility, communication facilities provided to each operator as a remote unit. Just now let us have a master can be converted into remote unit and vice versa. Speech facility, communication facilities provided to each operator as a remote unit. Just now let us have a master can be converted into remote unit and vice versa. Speech facility, communication facilities provided to each operator as a remote unit. Just now let us have a master can be converted into remote unit and vice versa. Speech facility, communication facilities provided to each operator as a remote unit. Just now let us have a master can be converted into remote unit and vice versa. Speech facility, communication facilities provided to each operator as a remote unit. Just now let us have a master can be converted into remote unit and vice versa. This facility, communication facility, provided to each of the remote unit.
So now let us
have a master video on the remote unit. This
And the
facility,
EDM
characteristics provided to each of the
752,000 meters range.
so now
Accurate
let us
of
have
minus
a
5
master
video
video
on
on
the
the
EDM.
remote unit.
And the operating temperature is
And
and
the
the EDM
characteristics
characteristics
provided to
and the
each of
prisms are made from
remote
1000
unit.
meters range.
So now
Accurate
let us
of
have
minus
a
5
master
gas
video
by
on the
EDM.
remote
And the operating temperature is
and
and the
the
EDM
characteristics
electro-optical
and the
prisms are made from
remote
1000
unit.
meters range.
So now
Accurate
let
of
us have
minus
a
5
master
gas
video
by
on the
EDM.
remote
And the operating temperature
and
and the
the
EDM or random and the prisms are made from
remote
translate parts.
So now
Accurate
let
of
us have a
master gas by
master
and the operating partial
and
and the EDM or random and the prisms are made from translate parts.
So now
Accurate
let
of
us have a master
gas by and the operating partial coming to error
and
and the EDM or random and the prisms are made from translate parts.
so now
Accurate
let us
of
have a master
gas by and the operating partial coming to error
and
the
the
EDM or random and the prisms are made from translate parts.
so now let us have a
And the operating partial coming to error
and the
and the prisms are made from translate parts.
so now let us have a
And the operating partial coming to error
and the
and the prisms are made from translate parts.
so now let us have
And the operating partial coming to error
and the
and the prisms are made from translate parts.
so now let us have
And the operating partial coming to error
and the
and the prisms are made from translate parts.
so now let us
And the operating partial coming to error
and the
and the prisms are made from translate parts.
so now let us
And the operating partial coming to error
and the
and the prisms are made from translate parts.
so now let us
And the operating partial coming to error
and the
and the prisms are made from translate parts.
so now let us
And the operating partial coming to error
and
and the prisms are made from translate parts.
so now let us
And the operating partial coming to error and the prisms are made from translate parts.
so now let us
And the operating partial coming to error and the prisms are made from translate parts.
and
video. 3 videos. 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 3 videos
And here we can have a short video of the GPU. These are And here we can have a short video of the GPU. These are
అన్న చాలా మన దగ్గరనే ఉంది అనుకుంటా. ఐసీఏ అన్న బాబు. అన్న చాలా మన దగ్గరనే ఉంది అనుకుంటా. ఐసీఏ అన్న బాబు. అన్న చాలా మన దగ్గరనే ఉంది అనుకుంటా. ఐసీఏ అన్న బాబు. అన్న చాలా మన దగ్గరనే ఉంది అనుకుంటా. ఐసీఏ అన్న బాబు. అన్న చాలా మన దగ్గరనే ఉంది అన్న చాలా మన దగ్గరనే అన్న చాలా మన దగ్గరనే అన్న చాలా మన దగ్గరనే
Now let us see the 3D trial iteration. 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 Now let us discuss the digital elevation model. A digital elevation model (DEM) is a three-dimensional illustration of a surface, typically a terrain region. It's a grid-based structure having array numbers oriented to depict the terrain attributes such as slopes or aspect value. In simple terms, it is an accurate digital representation of the topography. You roam around with a digital elevation model right in your pocket. Got confused? It's nothing but how we are using the Google Maps in our phones. So in the image, you can see the digital elevation model of a terrain on the Earth's surface. Digital elevation model can be done for the Earth's surface as well as other planets' surface. It quantifies the characteristic of the land. It can be represented as a raster, which is a grid of x and y coordinates, or a vector-based triangular irregular network. Each unit of digital elevation model is in the form of a square. The overall shape of the digital elevation model grid can be square or the rectangle. Digital elevation model is often confused with digital terrain model and digital surface model. Digital terrain model will give us the only data related to the plane Earth surface. Coming to digital surface model, it will give us the data related to the plants or any buildings or any elevator on the Earth surface. Digital terrain model represents a bare ground without any plants and buildings, in contrast to DTM. Whereas digital surface model represents the Earth's surface and includes all objects on it. TM is used as a generic term for DTM and DSM. And digital elevation model generation techniques these are generated through multiple means and techniques. The most relevant techniques are as follows. First one, using survey topography, contours and point heights. It is a spatial interpolation technique. It is done with the help of geographic information system, that is GIS. The data of the topographic map is scanned and digitalized to form sample elevation points and contours. A digital elevation model is formed by merging these two data. This method was used extensively before remote sensing came into existence. Coming to second one, stereo pairs where spot and cartosite data sets, etc., where the cartosite satellites are used. In the stereo pairs are a pair of flat perspective images of the same scene attained from slightly different points of view. It is a remote sensing technique. Some devices particularly help to capture such images. Data sets are attained from spot and the cartosite satellites for the same. Coming to third case, that is thermal infrared data. This method uses remote sensing. The radiation given out by the ground surface is detected. Coming to radar data pairs, a technique called SAR interferometry is used to attain a pair of perspective images from radar data. And Sentinel is a popularly known satellite to give radar data pairs. And LIDAR data, where LIDAR is an acronym for the light detection and ranging, is a well-known remote sensing technique. A highly accurate 2D or 3D database of the surface and can be achieved using a laser light. And the image you can see, Carolina Bay is a place which was taken a shoot by the LIDAR digital elevation model. And the light detection and ranging has a high demand, most often used to generate digital elevation models. It is cost effective as compared to photogrammetry, a method to obtain details of physical objects on the surface. Now let us see the digital elevation model applications in civil engineering point of view. The DEM can be applied in the surveying, certain field calculations, risk assessment, site planning, urban planning, and water resource management also. Coming to first case, in the surveying, the digital elevation model is most used to get conventional topographic data of a particular region. Soil mapping and geological studies can also be done by using the digital elevation model. Cut and fill calculation, earthwork calculation, especially for roads or railroads, can be done using the digital elevation model and the ArcGIS software. The ArcGIS is a software where we can create all these digital elevation models or DTM or DSM in the software. Coming to risk assessment, A seismic survey can be carried out using digital elevation model. The rock structure will give insights on threats such as landslides and earthquakes. Flood management can also be done after a thorough study of the topography. Coming to site planning, topography and slope are studied for planning site layout. The planning has to be considering underground utilities, and DEM even provides accurate data on the same. Coming to urban planning, architects and engineers can plan the residence users' visibility of a proposed building, taking into consideration the surrounding aspects. And finally, DEM can also be used in the urban planning and water resource management. Contours, elevation points, and catchment area details of a water body are obtained from the digital elevation model. Volumetric calculations regarding flow acceleration and flow direction for building reservoirs and dams can be done. And this is the image taken from ArcGIS software, the digital elevation model used for the urban planning. The digital elevation model can be created using remotely sensed data or by spatial interpolation technique. It also gives a digital quantitative model of a topographic surveys, and DTM represents a bare ground without any plans and the buildings. It is used to get a digital representation of the topography. Now, let us see the digital elevation model. Just now we have discussed digital elevation model can be represented in the grid form, that is rectangular or square form. This is already we have discussed that digital surface model includes all the buildings and all the trees and so on which are present on the earth surface. And the digital terrain model which covers only the plain terrain on the earth surface. It does not cover any buildings or any trees or any mountains or any elevation above the earth surface. This is a 3D representation by using the digital elevation model. These are the images which are taken by using the digital elevation models.
all the participants, all the participants, you can ask any queries to madam. Thank you very much, madam, for giving a wonderful presentation on modern surveying. Thank you very much. And I request all the participants to unmute yourself and ask any queries. Please, some of the participants are on their video. Please mute your video. Please switch off your video, sir. Thank you, sir. I request any participants who are willing to ask any queries. You can ask your queries, and you can, if you want to ask, you can ask in chat box. Please. Haripriya madam.
Yes, sir.
Um, Thank you very much, madam, for your wonderful session for day 2 on modern surveying. And it was a very good presentation. And we have seen the latest technologies that are being used in surveying. Uh, thank you really so much, madam. If you want to speak, you can speak for a few minutes. In meantime, I request all the participants to ask any questions for madam. And at the end of the session, we are going to post the feedback link in chat box. Okay, it will be disabled by 2. So please, as early as possible, please fill the feedback link. Thank you. Okay, madam, continue.
I thank all the BITS management and for providing this wonderful opportunity. And the participants, and just now we have discussed about the 2 points. First one is about the conventional surveying and what are the instruments which have been used in the conventional surveying. And in the second one, we have covered all the modern surveying, its importance and its application, its engineering point of view and its usage. And we have also seen the latest techniques which have been used in the modern world. And thank you all for providing this for me. Thank you.
Sir, any questions from participants? I request to ask I request all the participants to ask any questions.
Hello, good morning, ma'am.
Good morning, sir.
Sir, when you are taking these points in the field, there was an example given by madam. A road survey is being conducted. How do we store these points in the total station? What is the procedure?
Madam, hello.
Hello. It's an interesting question, sir. And I have shown you a video on the robotic total station, sir, where without the manual help, it will be storing the data, sir, automatically in that instrument.
Now, what are the steps we follow to establish these points and store those points in total station, and we retrieve that point? Now, there is a lot of process. Now, just by seeing this video, I don't think someone can do a field survey. So what is that procedure or a flow chart through which you can
Sir, while taking, the total station will be storing automatically the data into it, sir. It will be storing automatically, sir.
It is possible. See,
sir,
it is not.
Yes, yes.
Because,
sir,
see, here the wrong methods of teaching to the students. You have to fetch the local, what you call, point with reference